You are able to hear me? So I hope you are clear with the fundamental seriousness you need to keep on understanding the algorithm as a definition from the core computer sciences to the machine learning side. Okay. Anyhow, as we go on with the fundamental, we start applying them, you'll start getting more clarity. But as I already said, whenever you're working in your AML implementation, understanding bias is very, very important. In very simple form, if you're asking me, I'll say bias is nothing but an error due to overlay simplistic assumptions. Means you're just making certain kinds of simplistic assumptions in analyzing the code and taking it towards the predictions. Because of this overlay, your bias can occur. So according to machine learning, we consider bias as an error. Error doesn't mean that you see something when you execute your program in the form of you have this error. No, we are not talking about this error, which is anything to do with your programmatical syntaxes. Am I clear? So it is error as a value, what technically you should identify with respect to your domain of analysis. So bias cannot be recognized so easily if you are not technologically having the clarity of identifying the rule of the corresponding error by taking the values that have been generated by the corresponding machine learning model. Be technically very clear about that. Therefore, bias is the error that fundamentally is introduced by approximating a real world problem, where the problem can be complex or it may be a simplified model, that doesn't matter, but it is something that you are fundamentally trying to see that in confirmation to the real world problem with respect to the target value what we are expecting, we are on the approximation side, but we are not on the accurate side. So any system, remember one thing, any system which you are trying to develop, your client is saying that approximately I want this value, means he is ready to accept a state of bias in his particular problem and the solution. Am I clear? Be very clear. But once he says that I'm approximately expecting this value, then technically reaching to that particular value in approximation is your job. Suppose say like you're talking to a retail client and the client is saying that we are expecting an approximate turnover of the profits by 2.5% in next 3 months. Means is basically fixing 2.5% in the next 3 months for the profits to be increased. Now reaching the 2.5 is your job. Now technically he is happy with plus or minus, but how much of plus or minus he will decide, you cannot decide that. Is that point clear to you? So bias is an acceptable error technically in some commercial projects, but I don't think bias can be taken as an acceptable error when you're working with scientific projects. Am I correct? Especially when you're working in medical research, you're working in pharma research, you're working in genetic engineering projects. When you're working in any kind of space research, you cannot take bias as a acceptable criteria. Be very, very clear about it. So bias is always the error due to overlay of simplistic assumptions that are made by the model, which leads it to consistently miss the target output. So if I'm not taking the bias seriously, what happens? Simple, you'll never achieve your targets. You'll consistently start missing the target outputs, even after multiple different number of tests and multiple different number of trainings you're conducting upon your particular data. Be very, very clear about it. So how much is the bias? It technically depends. It technically depends. So we need to understand the characteristics of high bias. What are the fundamental characteristics of high bias? The model is making very strong assumptions about the data. Means whatever data is coming as an input, in that data, your model is not understanding the feature exactly by its impact, but it's assuming on the construct of the impact. So be very clear, where there are strong assumptions about your data, their bias is definitely coming. So can you tell me the strong assumption on the data can happen when? Can you tell me where strong assumptions can happen with respect to your particular data in the model? Can you tell me when this problem can arise? It's not exactly one-sided data run where if your subject matter expert and the domain expert are not having clarity about that particular problem and its situations. Am I clear? It is as simple as I tell you, your disease getting diagnosed by a general MBBS doctor to a specialized MD. Is there a difference or not? And another simple example you can take is your disease being diagnosed with respect to the accuracy of a RMP doctor to a professional MBBS doctor. Don't you think that here the construct of your subject matter expertise and your domain can make a problem now? So it's just as simple as that. Be very clear about it. It is as simple as you're taking a very constructive problem of a database and you're directly talking to a person who is a core programmer in C language. So when subject matter expertise and domain expertise is lost, you will go for strong assumptions about the data. Am I clear? This is what was happening in majority of the companies with a lack of intelligence and constructive exposure and experience of the subject matter expert, domain experts in the last few years with data scientists, the CTOs, CIOs, these people, because of their experience in the industrial process, they took the positions, but they're unable to understand the rule of the requirement and AML projects went for a failure. So be very clear. So when the when the ND going rule of assumption, we should check very carefully, is that particular person is going favorably by experience or not favorably by experience. Am I clear? So algorithm to algorithm, don't you think that you should think of favoring the value of the bias now? Yes or no? So can we fix a specific value for the bias always, even if it is a assumption? No. Be very clear about this. Am I clear? We'll check, Ranbir. Don't worry. Okay. First, let us understand the problem. The second thing, of a characteristic of high bias is model results are always underfitting, where the model falls to capture the underlying trends in the data. So how to identify my system is going on a bias? The model results are always underfitting. Now, please consider one thing. Whenever I say underfitting, don't think that the target value is low. That's wrong. Underfitting means what you are expecting as a prediction in relevance to that particular prediction value, your value is either less or it is more. Am I clear? That is underfitting. Underfitting means it's not technically trying to fit to your expectations. Is that point clear? So when you apply this model and you supply the data to the model, your algorithm is failing to capture the underlying trends that are coming in the data. So if you're having high bias, your model goes for underfitting. Be very clear about that. So whenever you are trying to go with a high bias always leads to low complexity in the model. Means the level of complexity that is expected in the rule of analysis with the algorithm, that is becoming very simple. I told you, the problem is actually falling under neural networks, man. You're trying to resolve the problem using linear regression. 100% high bias will come because linear regression will give you high accuracy. So if you are having high bias and you're not considering it very seriously, it is technically going to lead to the low complexity in the model. And not only that, it makes the model inflexible and unable to represent the true relationship between the features and the labels. Features means what did we say? The input properties, yes or no? And labels are nothing but what? Targets. So the true relation between the corresponding features and the achieved target, you cannot represent, you cannot identify it. So you need to always understand whenever you're dealing with the high bias, it is finally going to make your model to fail when it comes to the real-time implementation standards. Am I clear? That's where many number of projects in AI, they are very successful. Coming to ML, they look very practically wonderful in the development section. But when they go for deployment in production, they fail. You just imagine your presentation on the model to your client in the development process is creating high amount of expectations. When it really goes for production side implementation with all the fundamental investments are done and your model is failing with high bias, don't you think that your client is highly discouraged, man? Rebuilding your faith on the client is really going to be very difficult. Remember that. Therefore, bias has to be cut in the earliest stages itself by making multiple different number of discussions with the domain and the subject matter experts very seriously. That point clear? Finally, one simple thing I'll tell you, feature identification and target identification should be done very properly. So what are the fundamental examples of high bias you can take? As I already told you, a linear regression model is used to capture the relationship in data set that has non-linear trend with the high bias. Means your data is not actually linear. For a non-linear data, you started implementing linear regression. Don't you think that it's technically looking contradictory to one another? So you need to just check that. Suyesh, you cannot say that, okay? So don't you think that here identifying the problem is more important? If you're not analyzing the problem properly, then technically are you not pushing improper algorithm into it? So bias may not be a problem always with the data only. When bias can be a big problem because of choosing the improper algorithm. Am I clear? Therefore, a good machine learning expert should have ability of understanding and analyzing the problem actually fits into which area. That's very important. The same way, the linear model cannot capture the non-linearity, definitely will perform poorly even on the training data. Even if you're pushing training data for the purpose of your algorithmic model, it gives you very, very poor performance. That's what I'm saying. You talk to any of your friends who are already there in AML with experience, let us say in an experienced environment with 5 to 6 years, you ask them, they'll say, now I'm repenting unnecessarily why I came into this particular field. They technically say that. Are you getting me? The only thing when you ask them, they say, optimization is becoming biggest problem for me. Are you getting me? So optimization is the biggest challenge, man. So as your experience increases, please remember your industry never asks you what is this algorithm, what is that algorithm. They only push you into optimization fields. Can we really do optimization by hit and trial methods now? No. Optimization can be done with a great lot of research and analysis upon the data, domain, circumstances, situations, your programming model, everything will come into the picture. I'm not scaring you, but I'm making you clear with the fact of what is the kind of responsibility you should take. Sir, how I can recognize bias is actually happening? Can we anytime recognize the rule of any representative target of the AML directly with values presented in the form of tables or anything, man? Difficult. It is very difficult. Why? Because here we deal with millions of data points. Yes or no? That is the reason every time you want to identify the bias, you should always go for visual representation. That is the reason when you're attending any AIML interviews, he will check what is your ability in generating the graphs or charts. So on the graph, high bias appears as a model that is far from the target values. Means your target and the trained data model outputs will be very far away. Very, very far away. High bias can be recognized like that. Am I clear? Missing the mark consistently and showing a trend that doesn't fit the training data. So if you're just speaking on the construct of the charts, let us say, suppose like this is your corresponding chart, okay? Now my client's expectation of the target value is here. That's what is expected. But say like you started somewhere here very properly, but technically started shooting yourself like this. Now, don't you think that this is a high level difference from your actual target value? Now, what happened? Initially, it was looking good. Yes or no? Initially, your algorithm started going properly. But suddenly, something has happened. Suddenly, something has happened here, which made the constructive algorithm to get deviated totally. Now, that area of the features that are participating and the data that is coming in and how your algorithm went with such a lot of deviation is not that is something you should study now. If your visualizations are not there, 150% you cannot understand the bias bin. Are you getting me? On the graphs. That's the reason when you say you're an AI ML expert, they technically expect you to have the charting and graphing intelligence. If you are talking about Python, they'll definitely expect from you what? Matplotlib and Seaborn. If you are saying you're an experienced person who has already been part of the projects, they expect you to have intelligence in very high level reporting tools like or business intelligence tools like Power BI. Because only through visualizations you can speak with your subject matter experts and your domain experts or your CIOs or CTOs. With values, you can't speak with them. So visualization is your final target, but you should research and analyze depending on that visualization exactly which particular area of the feature and data point is making you move away from the corresponding target. Generally, many times people ask like, sir, what are the implications of a bias? There are many number of implications, not one or two. Models having high bias tend to oversimplify, leading to poor performance on both the training and test data sets. Either on the not on the training data as well as on the test data, your model will show you very poor performance. Now, your performance means not by speed, not by the criteria of memory or anything. Don't take the things in a wrong way. Performance means with respect to the achieving of the target goals. Am I clear? That's what for everything we use a term here. You don't keep it into computer science aspects, man. So what are the different kinds of impacts you can see? One is inability to capture complex patterns. Your model does not has the ability when you supply the data with features to identify the patterns in complexity. It loses that. So finally, it keeps the model simple. That's all. It always goes with a simplistic approach. You may not be having errors always, but systematic errors you can track always. Just now I just showed you. Suddenly it started deviating. Certain systematic errors will be there through which you can identify exactly how the model is doing high bias. Especially to identify the bias, high bias, within your training itself, you'll find very high level errors. High training errors will be there. Are you getting me? Means your model when it is run, after supplying the data and the corresponding features, it will be running away too far from the target, too far from the target. Next, when we say that the model is training, we are supplying continuously data with a trend of change. Do you agree with me? So remember, your model does not have a sensitivity to the data changes, lowest sensitivity to the data changes. Means whenever the data changes are taking place, it doesn't recognize those particular changes. There can be certain opportunities for increasing your insights with respect to your target, but it starts missing opportunities in insights. Opportunities for insights are lost. Means certain patterns, if they are included, you could have really reached the targets, but it could be missing those particular patterns without your knowledge. It will give you suboptimal performance on both training and test data. Now, once we design one AAML algorithm, For that particular problem and the corresponding situation, any domain, it's the same model that should work or not? Hello. When the problem is looking similar and the situations are looking similar, circumstances that are influencing are similar, even if the domain is changing, the algorithm should technically try to be the same. Remember that. See, the inference statements will be different. Inference statements will be different, but it is a generalization. Is that point clear to you? So once you design one, I already told you, don't get confused. Some students I'm seeing, they're getting confused. In the starting class, I told you, once one AI ML project is accepted to the corresponding circumstances and situations, it should be generalized. If you're having high bias, you will have a model that is having poor generalization. It does not reflect with the same kind of similarity in the different areas where the circumstances and situations are same. Generalization is lost. It is always going for underfitting. If you are not considering the bias and you are ignoring it, be very clear, it becomes very difficult for you to detect anomalies. The rule of logical mismatches cannot be recognized that easily. If you are having high bias, your model will have one very bad factor, that is inability to adapt to new trends. Means the model is not going to get ready for what? Can you tell me? The model is not going to get ready for what? Deep learning, reinforcement learning. Are you getting me? Where it has to pick up its own common sense to take the decisions by itself, even by the change of certain features. Yes or no? That's what I think we said in the definitions of DL and RL. Now, your model is definitely showing incorrect feature importance. Means certain features which are fundamentally important, it could be ignoring them. Finally, compromised decision making. Don't you think that it's almost all costing you with the application side of the project? Sir, how to identify the bias? Nothing, man. For any AML project, the target value is given by client. The target value is given by client. Now, reaching the target value is the responsibility of your AI ML algorithm, which we call it as a model. If it is not happening, you are in bias, man. That's all. Therefore, when the client is saying, even if it is 70%, we are okay. Confirm that 70%. Are you getting me? Is that point clear to you? So, you are having error rate with respect to the constructor target. Be very, very clear about that. See, bias is talking about whether you reach the target or not. Error rate is telling you the ratio of how much distance you're having from that particular target value. Are you getting me, Pinto Singh? Is that clear? So, bias is a decision. You are confirming. Error rate is a numerical state that is telling you how much distance you are basically from the actual target, what you should expect. So error rate will tell you how to make a correction. Bias will only try to take a judgment. Are you getting me? Decision. Is that clear? So when you identify a bias, you should consider the error rate to correct your algorithm. Separate it for correction state with respect to your particular abilities. Is that point clear to you? So for every time you technically achieved your target, remember one thing, you're implementing one algorithm and model. With your first shot itself, you got 100% accuracy. With respect to the target value, what we got? Shall we be happy? No, no, no. Okay. That also can be a false positive case. Are you getting me? So, getting 100% accuracy also can be one level of constructive bias where certain features that are really affecting the system for false positive you are not identifying. Am I clear? Generally, in medical sciences, you find doctors speaking sometimes, all the parameters are not, all the parameters are looking good. We don't have any problem in the diagnosis reports of this patient, but we are not understanding why the problem is not getting controlled. Now, that is a false positive case. Am I clear? Means something they are missing in the process. Some parameter is missing. Means what is missing? A feature is missing. Are you getting me? Some feature is missing where the output is showing that it's not achieved, but your constructive diagnosis reports are showing that you have achieved it. So, are you understanding the complication of AML when you're talking about targetsman? Therefore, you reach the target also, you cannot believe it, whether it is happening or not. Therefore, don't you think that AML projects need more amount of different dimensional testing procedures? So try to check that. Therefore, getting 100% accuracy doesn't mean that it's done. When you generalize the algorithm, then you'll come to know that something bad is happening. Therefore, every AML algorithm should move towards what? Generalization. Are you getting me? So when you put it into generalization, then you'll come to know whether any things that are essential you are missed or not. Therefore, lesser value is definitely a bias. Equivalent value also may be having a certain state of bias. Higher values are definitely biased. So higher and lower, it's fundamentally sure. We are considering that it's a bias. But sometimes equivalent value also should be taken very seriously for research and analysis. Are we going perfectly to the system or not? Am I clear? No, 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 Ranbir, you cannot say that. Are you getting me? Because remember, can we standardize features for all the domains in the rule? No. So feature analysis, see, that's what feature engineering is one of the critical areas of your AML implementations. Means if I supply all the features also, depending upon the domain of requirement, the algorithm should have the ability of removing unwanted features or including the required features. Are you getting me? This is very, very important. So don't you think that your model is expected to be more mercuric by nature in adjusting to the rule of the requirements and circumstances? So be careful. Generalization doesn't mean that everything is same. Okay. Generalization means that it is gaining the confidence and common sense to adjust its features by the rule of the requirement of the problem, domain, situation, and circumstances. Environment. Are you clear, Ranbir? Any confusion? In any number of areas, we'll see. Definitely, we'll check with very simple programs how we can think on bias. Okay, you leave it on my shoulders about that. Got it? Now, coming to the construct of the variance, there's another component that we need to consider. Variance is also one kind of error. Many times people misunderstand the error of variance and error of bias are same. People generally don't have a fundamental experience to like differentiate between these two. So remember, variance is an error due to sensitivity to small fluctuations in the training set. Means you're making some small kind of changes within your training data. With those small changes, it's showing huge gaps in your particular target values. Means it's becoming too sensitive to the corresponding state of the changes in the training set. Then we say it's variance. So variance is the model's sensitivity to the smallest fluctuations or variations in the training data set. So variance always indicates how much the model's predictions would change if it were trained on different subset of the data. Means the same model, when we are taking it into some other kind of subset of information, how much of prediction variance will come, or how much sensitively it is going to change its target values that fixes the variance. So if we are controlling the variance very properly, don't you think that we are making the model go towards generalization? Many times students ask one question, sir, what is the perfect bias and variance value? No, both should be trade-off. Be very clear. Are you getting me? Adjusting of the variance can make you move towards the bias. Adjusting the bias can make you go towards unwanted variance. Therefore, these two should be balanced in the ML model. Am I clear? So characteristics of high variance are what? The machine learning model, whatever you have designed, it captures even the unwanted data and the noise that is existing in the training data also, and it will try to show you the results. So if you're not, can you tell me, in order to see that you're controlling your variance very effectively with the statement what I showed in your screen, what is your main responsibility as an AML guy? The point what I'm showing on my screen, what is your responsibility? Can you tell me? You need to reduce the noise means what? You need to have very high level skills in data cleaning. Am I clear? Data cleaning, consolidation, scrubbing means sanity check, intelligence should be there. Am I clear? We call this in AI ML as exploratory data analysis. You need to have EDA skills. The second is variance always results in overfitting, where the model learns both the underlying patterns and the random fluctuations in the training data. So bias is always taking you where? Underfitting. Your variance is always taking you where? Overfitting. Be very, very clear about that. So you need to analyze. Your model is underfitting, means you should adjust what? Bias. Your model is going for overfitting, you should adjust what? Variance. Now you should adjust your variance and bias in such a way that both gets balanced at some particular level to an acceptable underfitting and overfitting by the client. Am I clear? So when you're dealing with your variance, what happens is your model starts learning both the underlying patterns and random fluctuations in the training data. Whatever pattern is coming, it starts learning from the pattern, but it becomes too sensitive towards certain kinds of changes that are happening in the actual data and considers that data also. It includes that data also, which is noise actually, and then it works out. So noise is participating in your particular model means you are not having proper cleaning agents in your particular system. Am I clear? high variance will always leads to keep your model with high complexity, causing the model to become overly sensitive to the changes in the input data. It is as simple as I tell you. You really can work with linear data with a linear regression, but technically you're pushing that particular piece of the model with something like convolutional neural network, CNN, very high now. Okay. So machine learning cannot be done just to prove your intelligence in the algorithm. Be very clear about that. Ranbir, you are nearest to the target point. The more nearest you are to the target point, you have balanced your bias and variance. Your target is always the construct, okay? So check that. See, a vehicle running on the road with a speed of suppose say like 120 kilometers per hour is always expected to be in a safe zone of not getting into the accident, being or keeping at least 20 meters of distance from the vehicle in front of it. Okay. All are very clear. 120 kilometers per hour speed, you're traveling on the superhighway. You do not want to meet yourself with an accident to the vehicle in front of you. You should see that you are keeping at least 50 meters of distance. Now, this is a very straightforward formula. But don't you think that there are many number of features that will play a vital role here? The sensitivity of your clutch, the controlling of your particular gears, the application towards your brakes, and the corresponding state of robustness of your brake pads, the kind of road on which you are traveling at that time, the amount of mass that is existing in your vehicle, the type of product or the goods that are being carried by the vehicle, these all things also play a very vital role or not? If you take the formula from the physics and if you apply, why then many number of times, even if the vehicles are keeping a safe distance, also accidents will take place? You find people saying that I'm just going at 80, but I don't know how the accident have happened. You did not consider, you're only concentrating on accelerator, clutch and your gear and the brake. But there are many other features, no, that influence your criteria. So you cannot take machine learning as a straightforward formula. AI can be taken like that. Machine learning is an influential state with your environments surrounding you. Few environments may not be exactly in your control or calculation. Therefore, what are the fundamental examples of high variance? A decision tree model with no depth restriction will have high variance. See, whenever you speak about a tree is a construct of arrangement of nodes and branches. Am I correct? Now, depending upon the depth of the tree or the height of the tree, don't you think that your decision making standards also will depend? So you're designing a decision tree model, man, but you're not restricting the depth. Any number of nodes your tree can have means so many different number. See, each time your branch is separating means what is happening? You're having a different kind of decision to be taken, yes or no? Every branch is one decision. Now, more the number of branches and the depth of the tree is not restricted. Don't you think that you could be having a greater of confusion in taking your decisions, man? So the model may perfectly fit for training data, including all its nuances and noises, but will perform poorly on new data, unseen data, because it is too specific to the training examples. So I can write decision tree. One of the first question interview will ask you is, what was the depth you have restricted for it? If you sell any value, then they'll say, why did you prefer that depth to be the optimized depth in your decision tree? Question will never come from the interviewer. How did you build your decision tree? Remember that. Now, what is the way we can put visual representation? On the graph, high variance appears as a model that fits the training data perfectly, but basically it starts trending and fluctuates widely when applied with the test data. When test data is applied, it starts fluctuating. The model predictions, they will start varying very greatly on the construct of the test data. In training, it looks very perfect. So if your training and test data implementations are going smoothly to the same level of the target identification, you can just think that you are balancing your variance. Am I clear? Sir, what are the implications of variance? Models with high variance, they definitely perform very well on training data, but they fail to generalize to the new data, that is the test data, leading to the poor performance on test set. Basically, when you're working in, they are training on the test set means what? They are overfitting on the training data. Am I correct? It is basically not fitting on the test set means your generalization is lost. In your training, you're seeing the perfect results, but when you're keeping it to test, you're not seeing it. Means there is a high training error. It is showing high minor changes whenever they are done with high sensitivity, it is reflecting. Maybe somewhere you have increased your complexity of the model, increased the computational cost unnecessarily. You will go for reduced robustness, means does not looks perfect for all the circumstances and situations. Whenever the new data comes, the predictivity accuracy will start decreasing. You do not have ability for interpretability of the model. It may be definitely trying to produce increased risk of misleading insights. Imagine these kind of things are happening in medical oriented projects in healthcare. One life is gone. You will have greatest challenges in model maintenance and updates. You will be having potential for model instability. Suddenly, anytime by circumstantial changes, model can fail. Bias is basically correctable, but variance should be immediately considered seriously. Am I clear? First, keep clarity on these two things. Whenever we ask students, can you explain me what is variance in AML? One very problematic state of answer we get is the variance from the statistics they'll explain. Do we have anything to do with statistics in this part of the discussion we did, man? So try to understand the question very carefully. Are you getting me? If it is statistics, he'll ask you from statistics only. There was certain terminology, because it is matching, don't try to mislead yourself. I'll just discuss few more things on this, and then possibly we'll start going with now two programs that can tell us how to identify the bias and variance. Okay. See, Pinto Singh, test data is which data? Real-time data only, no? Training data is historical. Are you getting me? Test data is always which data? the data that is coming from the real time. So on your training, it's going good. The moment you're putting your test data, you're finding the variance, means what? Overfitting is happening, no? So how we can dare to take it into the production side with real-time implementation directly? No way. So no project in AML will move into the actual production and implementation until this bias and variance trade-offs are not taking place. Are you getting me? So just see that you're not keeping improper standardizations into these terms anywhere. That's where we share the videos, because at least 2-3 times if you listen and revise, your maturity in thought process to the points what I'm speaking will increase. Are you getting me? So don't hesitate to revise the videos multiple times. Even if you're reading any particular book or anything, they will never be clear to you, because discussion is something different than you just take static state of that particular data in the book and you start reading, because whatever points I'm speaking with you, no author can directly put them on the constructs, yes or no, as it is as a dialogue. So do we have any bias variance trade-off? Yes, we have. But that is once again a discussion, not something like a formula directly. We'll just try to put our effort on that area. Okay. So tomorrow will be the last demo link for human. From Monday, we are only including those people into the session who have done with the fee payments. So you have your time to think for another 48 hours. It's really happy that you have been part of my sessions for so many number of days, keeping all your patience. Thank you very much, gentlemen. Once again with you tomorrow. Have a nice day. Take care of yourself. Have a great day. Yeah, tomorrow we'll be having. See, until I complete this theoretical and conceptual part, let us have the sessions, man. Okay? Such that we can just come into the practical side very quickly. Okay?